we look at number 1, we know the angle 2 is 95 degrees. Find angles 1 and 4. Okay, well, I'm going to fill in the diagram. Angle 2 is 95 degrees. We want to find the measure of angle 1 and the measure of angle 4. Can we find one of these right away? Yeah, which one can we find? 4. What do we know for? 95. Why is 4 95 degrees? Vertical angles, and very good, they are congruent. How can we find the measure of angle 1? Yeah, why would we subtract that from 180? They're supplementary. They're supplementary because they are this type of pair. Linear. Yeah, they sit on a straight line. We call them a linear pair. We know linear pair angles add to 180. Please do 180 minus 95. What is 180 minus 95? 85. Now we know the measure of angle 1 is 85 degrees. And for fun, what would the measure of angle 3 be? 85. Questions over that?
All righty, moving on to 2. See what we got here. Given MA is congruent to TH. Ha! MA, TH. All right, so find X. Well, what's it mean to be congruent? What's congruent mean? They're equal, right? So I'm going to go ahead and mark my picture here. I know that MA is congruent to TH. So how can I set up an equation showing that? Set them equal to each other. So I'm going to say that 3x plus uno is equal to 5x minus 9. So set them equal. Again, when in doubt, portion out always, but when in doubt here early on, set two things equal. Doesn't work out, add them up, set them equal 180. Doesn't work out, add them up, set them equal 90. Basically 3 ways you solve. If you did those 3 ways, you probably solved about 80% of our problems for the most part. I'm rounding, guesstimating, but somewhere around there. All right, let's go ahead. What do? Let's try to move the smaller x. So I'm going to move this 3x. Minus 3x, see a 3x. I got 1 equals 5 minus 3 gives me 2x minus 9. There's that bear problem we have. You guys know what to do at this point. I'm going to add the 9, be gone. 1 and 9 gives me 10 equals 2x. Last step, divide by 5, x does in fact equal 5. Good. But am I done? Am I? You say yeah? Yeah, I'm done. It says find x, I'm done. What's that? Set 2 things equal. Copy down, set 3.
If we look at 3, we want to use this diagram where EF is the angle bisector of TA. Well, what do we know about angle bisectors? What do they do to the big angle? Yeah, it cuts it in half. So if it cuts it in half, what do we know about these 2 little angles? Yeah, they're congruent. So if this angle is 30, what's this other angle also going to be? 30. So we know TEF is 30 degrees. How can we find TEA, the measure of the big angle? Let's find that angle. Okay? Add up the 2 little angles that make up the big angle. So we do 30 plus 30, which is what? 60. So this angle is 60 degrees. Questions over that?
Flip it over. Look at numero 4. So, which one of these is alternate interior angles? Okay, so thinking about your angle relationships. We got about 5, we got 6 of them. Think about them, let's see. All right, so I'm just going to highlight them. Again, it might be a good idea to have highlighters the day of the exam. We're talking 3 and 6. 3, that's not what I want. 3 and 6. All right. So, are these alternate interior angles 3 and 6? Alternate means on opposite sides of the transversal. Interior means inside. Aaron, what are you thinking back there? Yeah. She shook her head, so I chose her. She said, yeah, they are inside, they're alternate. Very good. Let's just look, just for humor, it is A. But just to see, let's see what the other ones look like. 2 and 7. You know, I waited a good pause, too. Why is that dot there? Nope. There we go. Get some lighter here. What's going on? So we said 2 and 7. 2 and 7. Are those inside? No. So no way it's going to be that. They're both outside. 6 and 5. 6 and 5. Both inside, but are they sitting on the parallel lines? No. Special notes for that. 4 and 6. They're both inside, but they're alternate. Alternate means on opposite sides. They're on the same side. So it's not going to be those. Oh, I thought I could grab both of them at once. Can't do it. All right, let's look at the next one. Corresponding to 7. All right. So think what corresponding means. We're looking at 7. What angle corresponds? Think what correspond sounds like. Which one would it be? Which one would it be? Thinking. And Kat, what do you say? 6. She says 6 right there. All right. Those are corresponding angles. Are those corresponding angles? Are they? What type of angles are those? Vertical angles. They are not corresponding. The measures will be the same, but they're not corresponding. Yes, you. What? 3 with the upward inflection. Corresponding. Yes, that is going to be the same. Think about corresponding. They're sitting in the same corner. So I look over here. This 7's in the lower left. If I think about quadrants. So which other one's in the lower left? It is 3. So B is the correct answer there for that one. Number 6. Which pair of angles are alternate exterior? Let's look at 1 and 5. We know alternate means on opposite sides. Exterior means outside. Ugh. That's not going to be it because 5 is inside, right? Can't be it. What about 3 and 6? 3 and 6. Are those outside? These angles outside? Or are they inside the parallel lines? They're inside. Can't be that one. We're looking for exterior angles. 5 and 8? Oh, 8's outside. 5 is not. Process of elimination gives me 1 and 8. Alternate means are opposite sides of the transversal. Exterior means are outside. It is going to be D. Which pair is same side interior? Same side means they're on the same side. Interior means they're both inside. Yes, you, the hand raised. 3 and 5. He says 3 and 5. So he's saying B. I don't think so. 3 and 5. Are they on the same side? Check. Are they both inside? Double check. He's right. 3 and 5. D again. Question on those. Remember those angle relationships. You also have linear paired and vertical angles. All right. Number 8.
We look at 8. It says BC bisects angle ABC. Find the value of x. Well, what did we just say about an angle bisector? What does it do to the big angle? Bisects it, which means it. Good luck. A little louder. Yeah, it cuts it in half so that these two little angles are congruent. Well, if we know these two little angles are congruent, how can we set this up? Equal them to each other. Good. So we can say x is equal to 4x minus 30. It's a little different. I know we're used to taking the little x and moving it over, but if we do that, we're not left with anything on that side. So in this situation, we have to take the big X and move it over. So we're going to subtract 4x on both sides. X minus 4x is what? Negative 3x equal to negative 30. What do we have to do with the negative 3x? The x by itself. Divide. So x is equal to. I had to find x. Found it.
Done.
Over that.
Don't do it. Flip to the other side, please. Moving on to 11. Moving on to 11. So, number 11. On the following road map, Lakeport, road is parallel to Marina Road. If the measure of angle 1 is 72, what's the measure of angle 4? Awesome. I've got some information. I got a picture. I better be labeling the information on said picture. So I know angle 1 is 72. 72 degrees. And I know that those roads are parallel. So I'm going to say that those are parallel. And I want to figure out what this angle is down here. Angle 4. Angle 4. So what is going to be the angle of angle, or measure of angle 4? Emmett, 72. Because it's one of 4 choices. Why'd you pick 72? Okay, I like that. He said 1 and 2, so that means that's 72. Okay. Wow. So he's saying with this one, you'd have to first go to this next step. But I like this. If you're doing it your way, you're saying, well, these guys are alternate interior. That's 72. That's a vertical angle. That's 72. Yeah, that works out. You could have done one step, just one step instead of doing your process. But I like how it was. What about 1 and 4? What kind of relationship do 1 and 4 have, Shane? Alternate exterior, but your way works too, Emmett. Alternate exterior would work. They're both on the outside. Their measures would be the same. B is the correct answer. B is the correct answer.
Yeah. As long as you just have explain it, like a parallel pair and then.
Yep. As long as you have parallel lines, you know these are all true.
And basically every parallel pair and then one line with the line.
Transversal. That transversal cuts those lines proportionally. That's what it forces. Number 12.
And we look at 12, says find the value of x in the diagram below. How can we set this up to find x? Jason?
Add them to each other, make them equal to 180.
Perfect. That is the correct answer. You're going to add these up and set them equal to 180 because if you look, there's that degree symbol. That means we're dealing with angles. We know that angles sit on a straight line, add to 180. So we're going to do 2x plus 24 is equal to plus 4x plus 36 equals 180. You have to be super careful on this problem though. What it's really tempting to do if you don't recognize that we're dealing with angles. It looks like this line is cutting this segment in half. And those measurements are written above the segment. So it's super tempting to say, don't write this down. It's super tempting to do this. Okay. If we were dealing with segments and this was a segment bisector, then yes, you can do that. Okay? But we're dealing with angles. And we know we're dealing with angles because of the degree symbol. And we know two angles next to each other on a straight line add to 180. So that would not be the correct way. You just have to be careful, make sure you recognize if you're dealing with angles or segments. So what do we have to do first in solving? 2x, 4x, 24, 36. What do we get when we do 2x plus 4x? What do we get when we do 24 plus 36? And then now we have our bare problem, just get x by itself. Move the 60 over. Get 120. Divide by 6, so x equals what? Equals 20. Done. Right, we just had to find x. So we were done. If it asks to find a specific angle, we have to plug x back in.
Questions? Make sure you pay attention whether the degrees or segments. All right, 13. Got some other ones here. Got some information. Let's go. So in the figure below, if GE and DF are parallel, what is the measure of BDC? All right, I'm going to mark some stuff. Show them here. So GE is parallel to DF. GE, DF. Those lines are parallel to one another. And I want to figure out what the measure of BDC is. So where's that at? B, D, C. I'm looking for this angle right in there, little guy. How do I figure that out? Who's got an idea? Any plans here? Any plans? I know they're parallel, so that tells me a lot of information with them being parallel. How can I use some information to figure out what this guy is down there? Does anyone see anything? Emmett, got an idea?
140. B would be 140, so that vertical angle, so it has to be 180.
I like now what B we're talking about here. Do you say B, is this a B up here, over there, down low, or that? What are we talking about? The top one. So you're saying these guys go together. All right, I agree. They are the same. These are corresponding angles the same. So is that how you got down to here? So yes, he says this is the same. Again, it's the same reason earlier. They're alternate exterior angles. But he's saying those angles are the same because they're parallel, cut by transversal, they're the same. Well, that's great. But that angle, which is DBC, you get technical with me, that's not the one we're looking for. We're looking for angle D down here. How can I use this? Yes? Where'd you get the 180 from? Just making up numbers. What equals? What always equals? Oh, you made a green thing, you made it into a triangle. Yes, that's what we're going to do. So we know those two. To find this one, is our unknown, or X down there. You're exactly right. If you think about the green one as BDC as a triangle, triangles do add up to 180. So you're exactly right. She said 180 minus, she added these two together, so she did 140 plus 30, and she said that gives me 170. So I subtract 170 from 180, and that gives me a value of 10. So D is in fact 10. Again, there's multiple ways to get that same answer, but hopefully you're going to have to make it into a triangle. Questions to that one? Questions? Set, go! Unit 2, give it a flip.
If we look at Unit 2, what do we know about all the angles of a triangle? What do they add up to? 180. Now we want to find X. What are we going to do with these three angles? Add them together. Set them equal to 180. Well, combine your like terms. When we do so, 55 plus 54 plus 74 is what? 183. To get X by itself, what do we need to do with 183? Subtract it. X is equal to, what's 180 minus 183? Negative 3. That's okay. If your X is negative, that's fine. If that makes you nervous, why did I get a negative X? Plug it back in the check. If we take negative 3 and plug it in for X here, what's negative 3 plus 74? 71. Our angle measure was a positive number. That's okay. It just, X could be negative. Your angle or your segment or whatever you're trying to find can't be negative. So as long as you take X and plug it in, you get a positive answer, you're fine. That's okay. Questions over there?
No questions. All right, that means we're on to number 2. This guy. A little bit different than the one before. Now I got that angle out, I got that measure out there. This is one of my favorite ways of solving. How would you set this equation, Aaron? Yeah, you're exactly right. If this angle was inside, you would add them up to equal to 180. But because that angle is on the outside, that angle is what we call an exterior angle, angle on the outside. And we know that exterior angles in triangles are equal to the sum of the remote interior angles. The angles that are far away, sum means you add them together. She is exactly correct. She said add those together, set them equal to the outside angle. All right, why not? Let's go ahead. So 30 plus 4x plus 2 is equal to 8 plus 6x. very intimidating. Well, not very, but quasi-intimidating. Got a long string of numbers and letters, but we always know the next step will be combining like terms. So these guys go together, that guy, go together, and let's simplify this just a little bit. 30 and 2, give me a 32, plus 4x is still equal to 8 plus 6x. A little more manageable, I'd say. We know my next step is I want to get those x's together. Which one do you want to move? That's a great one. I moved 4x myself. Minus 4x minus 4x. Equal 32 equals 8 plus 6 minus 4 is 2x. There's that bear problem. There's the bear problem we've all been talking about. So let's go ahead and get that problem. What do you want to do now? Subtractify that 8. You got 32 minus 8 gives me a 2, 4 equals 2x. Last step, divide 5 by 2, divide 5 by 2. X does equal 12. Am I done? Yes. You guys see what I did there? I don't think you saw what I did there. See the colors I chose?
Oh, the Christmas.
I just made an upside down Christmas tree. You're welcome, guys.
Well, aren't you in the spirit?
Yep, very festive today. Where's my brown? It's a stump. There's a stump right there. Upside down Christmas tree. Or dreidel, however you want to look at it. All right. Questions? Okay, now it's upside down. All right, number 3.
We look at number 3. What congruent statement can be used to prove that triangle ABC is congruent to triangle DEC? When I have multiple choice, I like to rule out answers. Have we ever really talked about HL? Has that ever been an option? No. Oh, that could be an option here. Go away. Alright, roll that one out. What about C? How many pieces do we need to show that triangles are congruent? 3. How many do they have here? 2. So we know it can't be C. So if you have no idea what else to do, you now have a 50-50 shot at getting the right answer. Okay, but we know what to do here. Which one of these is going to be the correct answer? A. Why is A the correct answer? Because we have what kind of angles? Vertical. And vertical angles are what? Vertical angles are congruent. Okay, so if we know vertical angles are congruent, we can mark that they are, and we have an angle, and we have a shot. Questions over that one?
Numero 4. All right, let's talk about 4. Which congruent theorem proves the final statement about the proof triangle HBD and HFD? Well, let's figure out what they are, what they're asking for. It helps to visualize this a little bit. So I'm going to say HBD is that triangle right there. The other one is HFD. HFD. Right there. Whoa! Need black there. All right. Well, here's the problem. Is anything marked in that purple and green triangle? Nothing is marked. I totally agree with that. So we're going to have to mark something. Because there's no way one of those is going to work if I don't mark anything. Is there anything I can mark off the back about these two triangles? Shannon, what do you got? HD is the same. Why? What's that property that tells me they're the same right there? What do you say? Reflexive. They're the reflexive property. I agree. All right, great. Why do I got a side in there? No, still, there's all 4 of them have sides. That's going to help me out. Anywhere else? Jason, you see somewhere else?
Well, but since you have so many things marked on triangle ABH and GFH,
Yep.
you could, using one of the things, prove that they are congruent, and then say that the two sides are congruent.
He's exactly right. He's saying these two triangles are congruent, and they are, because angle, side, angle, angle, side, angle. So does it mean all their pieces are congruent? Yes, it does. So if their pieces are congruent, I can say, I guess this one has to have, too. So this is going to say that one's congruent, that one's congruent now, because they're the same, all the pieces are the same. And conversely, that means if that's true, what about these two little guys on the bottom, these two little triangles? It says the same thing. They're congruent, these two triangles, because of angle, side, angle, angle, side, angle. So won't all their pieces be congruent? Yeah. So I can say that piece is congruent to that piece. It's also shared side too. You could have said these are all shared sides off the bat, but I like what Jason did, say these triangles are congruent, so the pieces be congruent. So now how are the purple and green triangles the same? What property tells me they're the same? Side, side, side. I have no angles marked, but I know it's going to be side, side, side. Because I have three sides marked. 1, 2, 3, 1, 2, 3. Congruent.
You might even be able to prove that, like, HD is like in the middle because of
We don't have to prove it's middle. We know any since it's backed up like that, it's reflexive property, they're automatically going to be the same.
Hey, we look at number 5. And we're given this partial proof, and we know AD and DC are congruent, and angle A and angle C are congruent. Well, whenever you're given that information and it's not marked, mark it. So we know AD and DC are congruent, and we know angle A and angle C are congruent, so let's mark it. And we're trying to prove that these two triangles are congruent. Well, they have the first two steps down. Sometimes they separate the givens. We have to figure out what goes in statement 3 and reason 3. Okay, well, if we look at A, if we look at our options, BD is congruent to BD. Okay, super, isn't that true? By reflexive property. So it's really tempting to go, yep, that's the right answer. But let's look at this though. If we mark it, so that's congruent to itself, how would we say that these triangles are congruent? By what? Jason?
Angle, side, side.
Yeah, angle, side, side. Are we allowed to do that? Are we allowed to say angle, side, side in here? Oh, that's never ever going to be an option. Plus, 4 says side, angle, side. That's not saying side, angle, side. So A, not the answer. That one was there to trick you. Okay? Check your answers every time if you think it is. It might not be. It's saying that angle ADB is congruent to CDB by perpendiculars form congruent right angles. Well, did it mention anything about anything being perpendicular at all in our given information? No. So is that going to be an option? No, it didn't even talk about perpendicular lines. That can't be it. For C, it says angle ABD is congruent to CBD. Saying if two pairs of angles are congruent, then the third pair of angles are congruent. Well, we only have that one angle in each of those triangles are congruent. We don't have a second one, so C doesn't make any sense. Can't use C. So that means, by process of elimination, our answer is D. Because these two sides are congruent, so that these two angles are congruent, the side across from them are also going to be congruent. And that makes it side, angle, side, which is what we want. Okay? Questions over that? Sometimes with multiple choice, you just have to go through and rule things out. One thing regarding the multiple choice on your test, this is really important. There's going to be some questions, not all of them, about 4 or 5, maybe more, maybe less, that are going to be select all that apply. So there might be more than one answer. Okay? Couple of things with that. Let's say this question happened to be a select all that apply. So we know D is the right answer, and let's say, okay, A was also the right answer. You have to circle both and just both to get full credit for that problem. If it was select all that apply, and you just circle D, you get the problem all wrong. Or if it was select all that apply, and you circled A, B, and C, get the problem wrong. You have to circle both or 3 or 1 or none of the correct answers in order to get the whole problem. That's not necessarily our favorite thing to do. We would love to give you partial credit for that. The AIR test does not give you partial credit for those questions. So to help you prepare for that, we're also going to be doing that. Okay?
I mean, the main problem is I guess if you selected 3, you have a really likely chance of getting half or more.
That's the problem. It's all or nothing. You can circle all 4, and you're going to get it wrong, unless it's all 4. So it's that option. For us, if you circle it, we'll give you partial credit. So you just keep circling all of them. But for the AIR, it's all or nothing. So you got to make sure you're really carefully reading the choices there with that. All right, let's move on to number 6 here. The triangles to the right are congruent. Great. That means they're equal. Which of the following statements must be true? All right, we've got various measures. Let's see what's going on. So A is talking about A and D. A and D. So we know they're congruent. We know order matters. Are those 2 angles congruent? Aaron, shake your head no. For the video, the camera back or the recorder here, just so you know. Aaron, why you shake your head no? Because they're not. But have that be the record. It's not. Why? It's because of location. Order matters. We said AB. You got ABC. That should match up with DEF or EDF. Excuse me. Well, angle A, if you look, is in between 2 sides, 2 tick marks and 1. Is D in between 2 tick marks and 1? No. Since it's not the same location, that means that is not congruent. Let's look at the next one. We're talking AB. Let's go this one. Let's go BE. Let's go in AB order. B is congruent to E. Is B congruent to E? Are those in the same location? No. Again, if we're looking at angles, it's if the one on the left is between 2 tick marks and nothing. It's between 1 and 2. That can't be right either. So it's not B. Moving on to C. A, B, and D, E. A, B, D, E. One's got 2 tick marks, one has 1 tick mark. Their measures are not the same. So, no go with that guy. So, the answer is none of the choices, obviously. Can't be any of the choices, right? No, it's going to be B, C, and D, F. Because look, here's B, C, here's D, F. Neither of them have tick marks. So that means they're the same. So this is your option. It is option D. That is your correct choice. Question on that one. All right. Cooking with butter now. Flip it over to the back. Number 7. I like number 7. 7's a good one. If triangle ABC is congruent to triangle DEF, measure of angle A is 50, measure of angle E is 30. What is the measure of angle C? Oh, very confusing. Very confusing. Why is this confusing? What? Who's saying that? Oh, you. Dad. It's like a ventriloquist. I'm looking over here. Somebody. Yeah, there's no picture. So how about you draw a picture to make it a little more easier for you to visualize it? All right, I'm going to try to freehand my best triangles, but, you know, I'm not the greatest. But I'm going to try my best to make 2 identical triangles. That's pretty good right there. I'm going to draw exactly the same one. Draw the exact same one. Boom! Did it. Pretty good. It's pretty good freehanding by me.
It's a little bit off.
No, it's pretty good. I mean, if you just stack those over top, nearly identical, almost like they were cloned, but it wasn't. So I'm going to say this is A, B, C. And again, order matters, so the other one better be D, E, F. Change colors, D, E, F. And now that I have that picture down, I'm going to go up here and mark my, or fill in the values I have. Angle A is 50. Angle E is 30. And I'm going to find out what angle C is.
Where are we?
We're on number 7. Number 7 right there. Look over right there at the top. All right. So, who's got a plan? Plans, ideas. Anythings? Nothings. Nothings. skip this one, chalk it up as a loss. Derek. It's on the same line. You're talking about 50 and X? Those are on the same line? They are sitting on the same line. I agree. I agree. Doesn't help me. You just pointed out they're on the same line. I like it. I like it. Good job. Leah. How'd you know B's 30? They're exactly the same. So since B and E match up with one another, exactly right. So that is also 30 degrees. These are all degrees as well. That is 30 degrees. Okay. How does it, Lauren, how's this help me out now? You add them up and set them, subtract from 180. Very good. That'll do it because this is a triangle. We know a triangle adds up to 180. So she's saying add those up and set them, subtract 180. All right. Because they're on the same line. Back to Derek back there. So when I do 50 plus 30, I get this. 80. Okay. So these two are 80. Go back to a triangle, adds up to 180. Subtractify that 80. Get your calculators out. I know that X is going to equal 100. So X is 100 degrees. It's pretty hot. Like outside.
But it feels fine now.
Because it's, 4 degrees outside. All right, here we go. Ready, set. Number 8.
For aces, which pair of triangles can be proven congruent by angle, side, angle? So we need two angles with a side in between. We'll angle. Never mind. What? Question? Oh. So we look at A. A, we only have one angle and one side. So is that a possibility? Nope. That's not gonna be it.
Not to mention you can't prove the other one because
Yeah.
It could be any size between the two things that are confirmed.
Yeah, there's no other information to maybe prove that another angle is congruent. Good, Jason. So that can't be it.
Always gotta assume with angle things that are not scale.
Yeah. If we look at C, what about C? Is that a possibility? What about B? Does B work? No, B we have side, angle, side. We have a bow tie triangle. Those angles are congruent. We want angle, side, angle. That one doesn't work. Same thing with D. Bow tie triangles, those are congruent, but again, we only have two pieces, and we need three of them. But we said C doesn't work. But does it? Oh, it does. How? Yeah, very good. Then you have shared side triangles. So that guy in the middle is congruent to itself. So we have angle, side, angle. So that would leave us with okay. Questions over that? All right, let's take a look at 9. Similar type of question. Says which pair of triangles can be proven congruent by angle, angle, side? Which one do you think this is? Yeah, very good. D. Because again, similar type of question. These share a side, so that guy in between is the same. Angle, angle, side. This doesn't work. We don't have enough info. Same thing here. Yeah, those are congruent. Not enough info there. These do share a side, but we have that forbidden angle side. That one doesn't work either. That leaves us with questions over there.
Well, I guess that means we're going to number 10. Oh, 11, 12, 13. All right, number 10 up here. Based on the given information in the figure to the right, how do you justify triangle JH, and JJ Abrams? No, HJI. So look it up here. What do you got? Jason, idea? Hold on, thought. I'll come around here in a second. We'll get you. Hold that thought. Think about your answer. It will go. So based on what we have here, how can I justify this? Do I have enough pieces? No, I only have 2 in each triangle. There's only 2. Shared side. Which side's being shared? JH. So that is shared. So what property tells me that these are congruent? The correct answer is
Would it be possible
Side,
to
side,
have
side.
it so, would it be possible to split these on right
the
angles?
correct answer. Number 11 back there, everyone listening here. So in the figure to the right, which theorem or postulate can you prove that triangle ADM is congruent to ZMD?
I was just one with the regular.
It's kind of hard to see, but there's something going on. Shane,
Have these, this goes here for that, and this goes for that.
he says they're both sharing MD. Yes. I know it doesn't look like it, but these are shared side triangles. You don't see these very often, but they're overlapping one another. All right? So they are sharing this side. So what property do they have in both of them? Just look at one triangle. Side, angle, side. Other triangle, side, angle, side. Yes. It is SAS.
Again, this packet is due the day of your exam. It is worth 20